Check it.
Okay, welcome back. Today we're going to start graphing rational functions for real. Now yesterday we learned how to find some of the ingredients, well most of the ingredients of a rational function. We learned how to find holes and vertical asymptotes, x and y intercepts, horizontal asymptotes, and for the honors class, slant asymptotes as well. Okay, so we're going to be taking those things and we're going to be using that to graph actual functions now. And basically the only thing that's missing, the only ingredient we need to add to this is making a table and getting some more points besides just the x and y intercept, because those are just 2 points right there, right? Or maybe a few more points. Maybe there's 2 x-intercepts or whatever. But the point is you need a lot more points than that, so you're going to have to use a calculator, make a table, and then you have all those landmarks, the asymptotes, and you also have more points, and that's going to create a better picture. Okay, let's get started here. So we have graphing rational functions. Now this is just a little review of what we talked about yesterday. Okay, find your vertical asymptotes in holes. How do you do that? You set the denominator equal to 0 and you look for the discontinuities, right? You find your horizontal or slant asymptotes. How do you do that? You look to see if it's top heavy, bottom heavy, or balanced, right? You find your x and y intercepts. You know how to do that. You set x equal to 0 and you solve for y, or you set y equal to 0 and you solve for x. And then here's the new stuff. Plot more points as needed to get a fuller picture. And that's what we're going to be doing. Okay? This last thing at the bottom here, use a grapher to find the maximum, and we'll talk about that at the bottom. Okay, so here's a function, and we're going to find all of these things. And I've made a little list here to help us remember what to do here. Okay, so the first thing you want to do is find the discontinuities. Okay, the places where the denominator equals 0 is going to cause a break in the function, right? Those are called discontinuities. The function will be discontinuous there. So the way we find them is by factoring everything, fully factor everything. So let's do that. Now the top is just an x, so it's already factored. The bottom, you can use AC method, but that would not be necessary here, because if you notice, there's a GCF. There's a 3 in all of these terms. And now this is x squared plus x minus 2, and that you could probably do with reverse FOIL, right? So why use AC method, which is a lot more work, when you can just use reverse FOIL? So now you take those factors of the denominator and you set them all equal to 0, and this will give you the places where you have a 0 denominator. Because if one of these factors is 0, it's going to multiply by the other factors and create one big 0 down here, right? Now 3 equals 0 you can't solve, because 3 does not equal 0, so forget about that one. X plus 2 equals 0, yeah, there's going to be x equals negative 2 is going to be one of the discontinuities. And then x minus 1 equals 0, x equals 1 is going to be another discontinuity. So we have 2 discontinuities, 2 discos, okay? And the question is, are they asymptotes or are they holes? Now, if you remember from yesterday, if you can cancel out the factor with something on the top, then it's a hole. But if you can't cancel it out, it stays permanent and it's a vertical asymptote, right? So neither one of these, x minus 1, there's no x minus 1 up here to cancel it out with. X plus 2, there's no x plus 2 to cancel it out with. These are both permanent discontinuities. So both of these are vertical asymptotes. So we have 2 vertical asymptotes. So we can come over to our graph now, and there's going to be a vertical asymptote at x equals negative 2 and one at x equals positive 1. So those are your vertical asymptotes. Now, any horizontal asymptotes. Now, if you remember horizontal asymptotes from yesterday, if you were top heavy, meaning the top function had a higher power than the bottom function, or the top polynomial was higher power than the bottom, then there were no horizontal asymptotes. Well, that's not happening here. We said if we were bottom heavy, meaning the bottom expression had a higher power than the top, that the horizontal asymptote had to be y equals 0. And that's what's happening here. The bottom has got an x squared, the top is x to the first power. So y equals 0 is your horizontal asymptote. Your ha is y equals 0. So we'll go and we'll draw that now. So we got our vertical asymptotes, we got our horizontal asymptotes, zeros, also known as, or aka x-intercepts. So that's the same as just taking the fraction and setting it equal to 0. A fraction is equal to 0 when its numerator, the top, is equal to 0. So you don't even have to look at the denominator. Don't even look down here. Just solve x equals 0. And well, that's x equals 0. And where does that go? That's going to go right here at the origin. Find the y-intercept. Well, that's probably going to be the same thing, because if your x-intercept is at the origin, then that's also a y-intercept, right? So our intercepts, there's only one, the origin, and we have 2 vertical asymptotes, 1 horizontal asymptote. So now that we have all those things in place, the next thing to do is simply to plot some points to figure out where the rest of the graph is. At the moment, we only have 1 point on the entire graph, which is this point at the origin here, which is obviously not enough. So the question is, what's going on with the rest of the function? You can't cross these vertical things, so most likely what you have is either a branch up here, or you have a branch down here. One of those two things is happening, not both, because both of them would violate the vertical line test. So it's one of those up there. And in here, okay, my guess, only because we see that there's going to be a point at the origin, is that you're probably going to cross through, you're going to hug on one side like that, and cross through and then hug on the other side. Either like that, or you're going to be hugging this side, cross through the horizontal asymptote, and go like that. One of those two is very likely. And then over here, it's either going to be something like that or something like that. Okay, one of those, that's my prediction. Okay, I don't know yet until we see it. It also could be, by the way, another possibility could be that you have something that looks like a parabola in here that's doing like that. That's possible. Or it's going down. That's also a possibility. All right. But let's see. Let's not guess. Let's find out. And how do you find out? Well, you need to plot some points. So this part's a little tedious in terms of, you know, the work we have to do, but it's got to be done. So let's do it. And we're not going to bother plugging in x equals -2 because we know that's an asymptote. We're not going to bother plugging in x equals +1 because that's an asymptote. But we need stuff that's, you know, surrounding and around those things, right? So how about we do 1 on either side of each asymptote here. So let's start off with, I guess I'll just go to -4. So -4, that's over here. -3. -2 we know does not exist. It's a vertical asymptote. -1. 0, +1 does not exist, it's a vertical asymptote, 2 and 3. So we'll do those points right there. Okay, there's my calculator, turn it on, -0.13. I'm just going to go to 2 decimal places here, that's good enough, this is graphing. And then -3 is -0.25. -2 does not exist. -1 is +0.17. Okay, very small number there. 0 is 0, which we already knew because we're at 0, 0 right here. 1 is an error again, and 2 is at 0.17. 3 is 0.1. Okay, these numbers are really tiny. So on this side, the numbers are really small but negative. That means you're going like that. And on this side, they're on the top. Okay, so this is how it's starting to look. Let me get this out of the way here. Okay, let's just do the points that we do have here. -4 is something -0.13. It's really, really small number, but negative. So we're talking, here's -1, 2, 3, 4. We're talking like right around here, for instance, okay? So I know it's gonna be hard to see. At 3, it's a little less negative, it's 0.25, it's like there. At 2, does not exist, okay? So what I'm thinking here is that this is what it looks like. It looks like it's asymptoting against here, and it's asymptoting against here. What about on that branch right over here? And then on this side, this is +2. +2 is a really small number that's getting smaller from 0.17 to 0.10. Okay, so that means it's asymptoting down like that on this side, and on this side it's going to have to asymptote. You can't cross a vertical asymptote, so it's going to asymptote this way. So what you have is something that looks sort of like that. Maybe that's not the best looking graph in the world, but something that, this is not the scale 100%, but it looks something like that. So really what we're doing here, we're still kind of guessing at the exact details, but at least we know that we're in this part of the graph, not this part of the graph. That's the whole point here. So by me doing the table here, I'm not exactly following all these little decimals here, but I do know that I'm above the x-axis because the numbers are positive, and here I knew I was below the x-axis because the numbers are negative. Now I could cheat and just look at the graph on the graphing calculator, but I'm not going to do that, okay? So please don't do that. Or if you're using decimals, wait till you're completely done, then check your answer. Now what about in the middle here, okay? We know we're going through 0, 0 here. At -1, we're positive. See that? Positive 0.17? So we're very slightly positive here, and like I said, it's probably going to go either down or up. This is positive, so it's going up. So I'm going to guess that we are going something like this. We're going to asymptote against the asymptote here this way. Okay, and then what about this side here? Well, we don't have any numbers between 0 and 1, unfortunately. We need like 0.5, so I'm going to have to go to my thing here. 0.5. 0.5 is negative point something, right? Negative, which means that you're going down. All right, and that means you're going this way. And you draw your arrow. Okay, so not an exact science in terms of where every single point is, but what you're really trying to figure out is where are you? Okay, where are you in this chunk right here? Are you above or below the x-axis? Here, are you above or below? Here, are you above or below? And once you figure that out for each one of these areas here, you can kind of assume that it's just kind of hugging the asymptotes after that. Okay. All right, so let's take a look at this on Desmos and see how close we came. So yeah, we got it right. Okay, so the purpose of making the table is not to get every single point perfect, but it's just to figure out where you are, because you could have had things that were up here, or this could be like a parabola in here. So just to figure out where you are, you plot points. Okay, anyway, there it is, same exact function, and there are all the ingredients there. Okay, let's try this problem now. And you can see this problem is actually simpler looking. It's just y equals x over x plus 4. Okay, less complicated looking. We still have to do all the same stuff though. So we don't have the list here showing us what to do, but we should be able to reason our way through it. Now the first thing we should do is look for our domain constraints. Where does this thing have a denominator that equals 0? Well, it's pretty clear. X cannot equal -4 here. So x equals -4 is going to be either a vertical asymptote or it's going to be a hole. Now, can you cancel out the x plus 4 with the numerator? And the answer is no. So it's permanent. It's not a removable discontinuity. It's a permanent discontinuity. So it's a vertical asymptote. Vertical asymptote at x equals -4. So we can go ahead and on our graph here, and there's x equals -4, our vertical asymptote. Is there a horizontal asymptote? Now, if you remember horizontal asymptote, you look for top heavy, bottom heavy, or balanced. Well, the power on top here is a 1. The power on the bottom here is also a 1, so it's balanced. So what you do with the horizontal asymptote is that you divide the two highest power terms, x over x, you divide them, you get 1. So your horizontal asymptote is going to be y equals, because any horizontal line starts with y equals, and it's x over x, which is 1. So y equals 1. So go ahead and draw your horizontal asymptote now. All right, what else can we find? X and y intercepts. How do you find the x-intercepts? You make y 0. So if you make y 0, this f of x becomes a 0, and you have x over x plus 4 equals 0. Now, you want to solve this equation. You have a fraction equal to 0. Well, the rule is a fraction is equal to 0 when its numerator, the top, is equal to 0. So don't even bother looking at the denominator. Just solve that. And you can see that is x equals 0. So we can come over here and put a point right there at the origin. That means our y-intercept has to be y equals 0 too, because if you think about it, now we can plug in 0 for all the x's. If this x is 0 and this x is 0, we have 0 over 4, and that's going to be 0. So our y-intercept is also y equals 0, which is, there you go. And that's pretty much it. We don't have anything else. However, now we can look at this thing. We have 4 quadrants to this graph, 4 areas. One here, one here, one here, and one here. And we need to know, are we above or below? Above or below for each section here, because you can't be both, right? If you have a piece here and a piece here, you'll fail the vertical line test, and you can't do that, right? So the question is, are you above or below here? And are you above or below here? Well, this one, we already have 1 point. We know that we're on the bottom, we're below the horizontal asymptote here. So most likely what's happening here, most likely, I'm just taking a guess here, is that you're going to hug asymptote, meaning that right there, and you're probably going to do the same thing there, right? And then here we have 2 possibilities. We could either be up here or we can be down here. We don't know which one. Now, is it possible that I'm wrong and that we're going to actually cross an asymptote here? Is that yeah, it's possible. We might break through and then hug it that way. That can happen, but my guess is probably not. Anyway, we're going to use our calculator. We're going to check basically the signs to see, are we going to be above 1 or below 1, and that'll tell us if if the numbers are getting really, really, really close to 1 but not going above them, that means we're asymptoting from below. So we'll go up here to -3, -4. There's your -4 is an error. Why? Because it's a vertical asymptote, right? -5, where x is -5, y is +5. So y is pretty high up there. So what looks like is happening here is that you're starting high, okay, and you're asymptoting this way. So that would be my guess there. Okay, my very educated guess. Now what's happening on the other side of x equals -4? Well, we'll bring back our table here. And this time we'll scroll down. So this is the same as plugging in numbers, except it's faster. X equals -4 was your asymptote right there. And then after that, you see that at -3, you're at -3. So there's a point, like a point we can actually use right there. -3 comma -3 is right there. Okay? And then -2 is -1. So that's actually right there. Okay? And at 0, you're at 0. We already knew that. At -1, you're at -1/3, 0.33. So you're about there. And you can see it's creating a shape, right? You can see it's creating a thing that looks like what I predicted before, which is it looks like it's doing this. It's asymptoting that way. This is what I think my graph is. And -6 was 3, so here's -6, 1, 2, 3. I don't want you to think that you don't have to use any points. You should use the points that you can use. And -7 was 2 and 2/3, no, 2 and 1/3 rather. So there's 2, 1/3, right about there. And you can see once you have a few points, you can establish your shape. And now when we check it against Desmos, there's the graph, and this was the vertical asymptote at x equals -4, which we had, and we also said y equals 1. And you can see, all right, there's the origin, there's the x-intercept, 0, 0, right? And also the y-intercept. You have the same horizontal asymptote, vertical asymptote. We're in the top left quadrant here. We're in the bottom left quadrant here. Sorry, bottom right quadrant here. Okay, looking at what we had. Okay, the only difference is that, you know, my graph is like kind of shifted like that. Okay, but other than that, yeah, there it is. Okay, let's try this next one here. So here we have a function, f of x equals 5 over this thing here. Now, once again, if you want to find the discontinuities, you have to put this in fully factored form. So there's a 5 up top. And on the bottom, we can factor this. Let's see, two numbers that multiply to give me -4 to add to give me 3. That'd be 4 and 1. +4, -1. There you go. So what are our discontinuities? X equals -4, right? If you set this equal to 0, and x equals +1 is what you get if you set this equal to 0. Are they asymptotes, wholes, or one of each? Well, you can't cancel either one of them, so they're both asymptotes. Vertical asymptotes for both. There's our vertical asymptote of x equals -4, and now x equals 1, which is over here. Okay. Is there a horizontal asymptote? Well, this function is bottom heavy, and if you're bottom heavy, your horizontal asymptote is the x-axis, y equals 0. Okay, any intercepts? Once again, to find the x-intercepts, you make y 0, and then you just look at the top. When does the top equal 0? Well, 5 equals 0 never happens. So there are no x-intercepts. Okay, what that means is that you're never going to cross this horizontal asymptote here. There's no x-intercepts. Is there a y-intercept? Well, if you make your x's 0, make this x 0 and make this x 0, you get -5/4, which is -1.25 in decimal. So your y-intercept is -1.25. Your x-intercepts, there's none. So -1.25 is your y-intercept. That would be like right about there, -1.25. So that's all we got. So once again, we have 3 sections here, 3 verticals that we have this area here, we have this area here, and this area here. And for each one of these, we need to figure out, are we on top or on bottom? Okay. Now, for this middle one, I'm pretty sure we're on the bottom here because we have a point there already. And we also know that there's no x-intercept, so we're not going to cross here. So we're not going to, we know this is most likely going to be doing this, right? This is going to be hugging, going down like that. But I don't think we're going to be doing this like we did last time. Why? Because we checked for x-intercepts and there were none. So this is what I'm guessing here is that this thing probably curves back down and does this. Okay, but we'll find that out when we plot some points. Now, so I'm guessing once again that there's going to be a loop here, and now the question is: are we up here, or are we down here? Are we up here, or are we down here? Now, once again, if you don't have a grapher, you can use a Desmos app. If you don't want to do that, you can just use a regular calculator and keep plugging in the numbers. Okay, so at -7, we're positive, but we're pretty close to the, we're only at 0.2, so we're like, I don't know, like around here. And at negative 6, we're at 0.35. So we're a little higher. So what that suggests is that we're getting, we're getting closer. We're asymptoting this way. And then when we get to negative 5, it's getting even higher. So my assumption is that this thing is going to end up asymptoting this way. Okay. I could check like negative 4.5 here and get better, estimates, but it's pretty much going to be just something like this. All right. Now, what's happening between, between these two asymptotes here, between 1 and negative 4 in here? Now, I already guessed that because we're not going to touch the x-axis and because we have a point down here, that everything is going to be confined down here. Let's see if I was right. Negative 4, that's an error. Okay. Negative 3 is negative 1.25. So here's negative 3, 1, 2, negative 3. Negative 1.25 is here. And then for negative 2, we have something that's negative 0.83 here. So negative 2, we're actually coming up a little bit. So we're like around here. Negative 1's the same. So my guess is that it goes up and comes back down. And yeah, this is kind of what I expected here. So we have a loop that's going to be going down. So here we go. You can just hug, the rest of it is just asymptoting. So just hug the asymptote on the way down here. Okay, there's one side of it, and there's the other side. All right, what about here? Are we up here or are we down here? Well, you see at 1, there's an error because that's a vertical asymptote. But at 2, you're positive. So you're above the x-axis, not below. So that tells me we're going to be up here. Okay, and let's just plot as many points as we can here. 2, 0.83, so not quite 1. That's somewhere like around there. 3, 0.35, that's coming lower. And they're just getting smaller and smaller. So, okay, that's good enough. So you can asymptote this way, and you're going to end up asymptoting this way. And there you go. That's your graph. You're graphing rational functions. You're becoming a human graphing calculator here. There you go. Now let's check this against Desmos. All right. Okay, there's the function, x over x plus 4. We have our vertical asymptote at negative 4. We have another one at positive 1. We have our horizontal asymptote at the x-axis. And yep, there it is. There's that loop that we were talking about. And there are the 2 branches that are up here in the top right and left corners there. Okay, let's try the next example here. Okay, so if you're in the non-honors class, meaning the academic class, you don't have to worry about this one because this one has a slant. Well, it will have a slant asymptote. Spoiler alert. If you want to stick around and see this example, by all means, stick around. Okay, so for this problem here, we have a function. We want to find all of the places where you can have a discontinuity, and you can see that x equals negative 1 is going to be a discontinuity. The question is it a whole or is it an asymptote? And the only way to know that is if you can cancel it out. Well, you can't cancel until you factor and you see what you really have here. So let's write this in fully factored form here. This is still x plus 1 in the bottom. That's factored, but what's this going to be up here? Okay, and we check that. That does work. Now, does the x plus 1 cancel out with any of these factors? No. So this is a vertical asymptote, not a whole. VA. Do we have a horizontal asymptote? Well, we're top heavy, and we were told that when we're top heavy, there's no horizontal asymptote. So no horizontal asymptote. But we also learned that if you're top heavy by 1 degree, okay, you will have a slant asymptote. And take a look. The bottom is a power of 1, and the top is a power of 2, where we're top heavy by just a single degree. So that's going to be a slant asymptote. And the way you find the equation of your slant asymptote is to divide the top by the bottom. Okay? Either using long division or synthetic division. Well, this is in the format of x minus c, so we can use synthetic division. Okay? Nice and convenient. What's my c? It's negative 1. So here we go. Negative 1 going into 1 minus 1 minus 6. 1 minus 1 minus 6. Here we go. Drop your 1. Now, what do you do with the remainder? Well, if you were paying attention yesterday, we don't worry about the remainder. The remainder is not going to be used. So what is this that you're getting here? This is going to be the equivalent of x minus 2. So what's your slant asymptote? Y equals x minus 2. We're going to graph this vertical asymptote. We're going to graph this slant asymptote. X-intercepts. Well, we learned that X-intercepts happen when the top of the fraction, the top equals 0. And we can use a zero product rule here. You're going to have an X-intercept at -2 and +3. So look how that's how easy X-intercepts are when you know what you're doing. This is simply going to be 2 and -2 and 3. Y-intercept. Y-intercept is 0 is when X is a 0. So make this X a 0. Make that X a 0. Make this X a 0. And what I'm getting here is -6. So y equals -6 is our y-intercept. So you can see all this stuff is really quick and easy to find. Okay? The intercepts very quick to find. The slant asymptote took a little bit of work, not much. The vertical asymptote also very quick and easy. Okay? And we can start putting those things here. And then after that, you just take out your calculator and fill in some extra points and you're done. All right. Vertical asymptote at x equals -1. We have a slant asymptote that's y equals x minus 2. It's just a slope of 1, right? You have a slope of 1 and a y-intercept of -2. You know how to graph that. So graph that line, but graph it as a dotted line. I'm going to graph it as a dotted red line here. There it is. And where are the intercepts that we found? Well, there's an x-intercept at -2, so there's a point right here. There's an x-intercept at +3. That's a point right here. These are very helpful because I know I'm going to be down here now and it's not up here. See? Very, very helpful. And a y-intercept of -6. So on the y-axis, -1, 2, 3, 4, 5, 6. And now we can grab a calculator and just fill in some of the points. But I can already tell what's going on here. And hopefully maybe you can tell as well. We're not going to be up here because that would, we have points down here, right? So that would violate the vertical line test. So very likely we have something that's going to be asymptoting this way and then asymptoting this way. And in here, it's most likely just going to be doing the same thing on this side here. So it's going to be asymptoting this way. And then, I don't know, maybe, well, this is where some more points would be helpful. And then like that. So this is my guess. You should be thinking ahead like this and guessing ahead. But let's just, now you take the points that we do know for a fact, okay, without the guesses, and grab the calculator and see what we get. So I'm going to grab my calculator. At +1, we're at -3. So right here, we're supposed to be at -3. So there's a point right there. At +2, we're at -1 1/3. So that's like right there. Okay. At 3, we're at 0. We already knew that. 4, we're at 1.2, which is about there. 5, we're at about 2.3, which is about there. 6, we're at about 3.4. So 1, 2, 3, 4, about there. And you can see that it's definitely following what we thought it would follow. And then 4.5 is right here. So yeah, definitely that thing that I drew before, it looks like it's happening. So that's just going to asymptote that way. And there you go. That's confirmed with the calculator. Okay, so let's see what's going on now on this side here. -1's an error because it's a vertical asymptote. -2 is 0. We already knew that. -3 is -3. So -1, 2, 3, -1, 2, 3 right there. -4 is -4 and 2/3. So that's right about there. -5 is -6. So -1, 2, 3, 4, 5, 6. That's right there. No, -7. And then 8 and 1/3. Yeah, we like somewhere down here. And -6 was 7.2. So that should be right there. So yeah, the thing that I was drawing before looks like it's coming true here. And then on this side here, I could plug in some points between -1 and -2, like decimals. But you know what? Let's just know it's obviously going to asymptote and hug the asymptote on the way up here like that. And there we go. Let's just check this against Desmos. All right. Yep. Looks like we pretty much nailed it there. Now, this one's quite a bit bigger, a little more complicated looking, but the theory is exactly the same. First, put this thing into fully factored form. That's been a theme that comes back a lot. So factoring is probably the single most important thing we learned this year. So how do you factor this thing? It's a fourth power. We don't know how to factor fourth powers, but remember, always take out a GCF if you can take out a GCF. And yeah, there's a GCF here. There's a 3 in all of these, and there's an x squared in all of these. So the GCF, the greatest common factor, is 3x squared. Now, once you pull out your 3x squared, what's left? Well, all that's left in this is x to the second power. All that's left here is 2x, and all that's left here is, well, 1. And now the bottom, check this out, is that. And you can see that's going to cancel out. So it's basically there's going to be a hole here. In fact, we're not done because we have to put this in fully factored form, and this is not fully factored yet. So let's keep going. Let's fully factor this thing. So this is 3x squared. That's as factored as that's going to get. But what about this? Can you factor that? Yes, you can. X and x. What are two numbers that multiply to give you 1 but add to give you 2? Hard one. Yeah, plus 1 and plus 1. And since the bottom's the same, it's also x plus 1, x plus 1. Okay? And now it's time to do the analysis. Disco time. I really should get some disco music and cue it right here like The Martian. But anyway, you can see that there's going to be a discontinuity at x equals -1 because of this. This becomes a 0 at -1. And this becomes a 0 at also -1. So the only disco is at x equals -1, right? And if you can cancel the disco out with the top, it's not an asymptote, it's a hole, and both of these do cancel out. So that means x equals -1 is not a vertical asymptote, this is a hole. Now, x and y-intercepts. Well, the y-intercept is what happens when all the x's are 0. You get 0 over 1. So that's just 0, which means the y-intercept is at the origin. So now let's look for the x-intercepts, okay? Now we know that the y-intercept is 0 there. That's also technically an x-intercept, right? How do you find x-intercepts? Well, you set the top equal to 0, okay? But before you set the top equal to 0, you need to simplify this thing. So we already said that you have to write down your discontinuities before you cancel anything out. But if you want to look for x-intercepts, you need to cancel these out now, okay? And all that's left is 3x squared. So when is 3x squared equal to 0? When x equals 0, okay? So that means your only x-intercept is x equals 0, which is the one here. So we only have one x-intercept, which is the same as the y-intercept, which is the origin. And we have no asymptotes, horizontal or vertical. And we have a hole, but we have a hole at x equals -1. So where is this function at x equals -1? And that's going to be 3 times -1 squared, which is 3. So technically, okay. So this is kind of a hack here, but I'll show it to you anyway. -1 comma 3 is where the hole is going to be after you cancel stuff out. If you plug it in, you've gotten rid of the thing that creates the problem, and now you'll see where it should be. The question is, what does the rest of the function look like? Well, I've taken the liberty of putting the function into my calculator already, and there's my table. And let's see, I'll just go from like -3 to +3 again, so that'll be right. It says at -1 you have an error, which makes plenty of sense because there it is. That's -1 is not possible. 1 comma 3, that's going to be right here. 2 comma 12 is already off the board. So I don't even know how to do this here. This is 8. So 9, 10, 11, it's somewhere up here. Okay? Now on the left side, -2 is also 12. So what that's suggesting is that we have a parabola here. Okay? On one side, it's going up this way. On the other side, it's doing the same thing. Now, so something like that. After you cancel out the discontinuities, once you get rid of your discos here, you can feel free to plug that in and see where the hole would be. Okay, so you learned a little calculus today. Calc is not hard at all, by the way. The hardest part of calc is getting your algebra straight. So if you know your algebra, calculus is pretty easy. Okay, and there you go. Let's take a look at it on Desmos. And yep, there it is. There's our 0, 0. Okay, all right, we're done with that. Okay, guys, we're done. See you at the next video.
Check this.